Section 9.3 and 9.4, the last two sections of Chapter 9, Math 103. 9.3 is large sample confidence interval for a population proportions. So here, before we actually go over all these, let's look at the examples here, okay? So what we mentioned earlier on 9.1 and 9.2, we mentioned that if we don't have proportion of the populations, let's say this is a large city and you want to find proportion of populations here, capital P is unknown. So in that case, you take some samples from different places and you want to make sure that your samples, they all have equal numbers. Like if you take 400 from here, you have to take 400, 400. And for all these, you establish an interval. And when you take the sample from each section of this city, then you calculate P hat, which is proportion of the samples. And then we also calculate E, which they call it margin of error. And then we finally, to find the p-value, proportion of population, we are saying the proportion of populations always is between sample proportion plus E and p hat minus E. This is the interval. This is a confidence interval, okay? So now, here, I wrote it here for you. What is a confidence interval? Confidence interval is interval that you think include the p-value. So you know the p-value would fall between these two numbers, okay? And confidence level, let's say is a 95%, means 95% of those samples interval that you're establishing does have p between those two numbers. Now, as explained here, 95% of all the sample interval generated have value of proportion of populations, and maybe only 5% of them doesn't have that. So like here, so the very first condition is we should always have the large number. Means when you take a sample size, make sure you take a large sample size. Like if you want to take 100 versus 500, if you have a larger sample, then you get a better result. With a larger sample, you have less error, okay? So to know whether you are taking a good number of samples or not, you always establish NP and NQ. If N, P, or Q, or 1 minus P. Some textbooks they say Q, but here they say 1 minus P. If NP and N times 1 minus P, when you calculate these two, if they both are greater than 10, then your conditions are met. And also you want to make sure that when you take a sample, is a random samples. So you don't go, if you know like one area of town that you know for sure people are going to be in favor, you don't do that. This is not random. Random is you just randomly select some numbers. And how do we calculate margin of the error? Margin of error, we discussed that in earlier sections, is from this formula. And then, so when you calculate the margin of the error, and we already have p hat, or proportion of the sample, you take proportion of sample and add and subtract to find that interval. You find the interval that your proportion population falls into that. And then here we said, you can be 95% confident that the actual value of population proportion always included the interval. So when you establish an interval, you're saying that your proportion of population should most likely fall between those two numbers. There are some terms that we need to remember, like these are the questions. In fact, a couple of problems are very similar to what you see here. The 4 key questions are this. Estimation. What we are doing, is it estimation or hypothesis testing? Is estimate. Why? Because what population characteristics you plan to estimate? We are trying to estimate proportion, right? So we are trying to estimate. A study type, is it sample data or experimental data? Is the sample data. Select the potential method. This step involves using the answer to the 4 keys. So we are using the sample data. And are we using 1 variable or 2? No, 1 variable, because you're just calculating proportion of populations. So that would be just 1 variable. How many samples? And explain that also. You need to know how many samples you're taking. And here is a good explanation for each of these, like why we are picking, because the answer to the 4 key questions are estimate, sample data, or category or variable. So 1 sample, consider constructing confidence interval. So the answer to all those questions are here. Now this example here, in this one, they are saying that the value of n is given, value of p hat is given. P hat is 52 out of, see here, they're saying the sample size is 52 people who have moved home. And as a matter of fact, this is example 4. In example 4, they're saying researchers studying relocation pattern were interested in learning about the proportion of US adults 21 years older who moved back home or with their friends. So they have taken a sample of 743 people between age 21 or older, and 52 of them reported that in the previous year they moved with their parents, okay? They have changed from living independently to living with their friends or relatives. So the sample is 52 out of 743. So you have your n. P hat is x over n. Out of 743, 52 reported. So that would be your value of x. So when you find a p hat, then to find the margin of error, you understand is 1.96. So you'd use p times 1 minus p divided by n. And then you're adding and subtracting. Now, what I did here was, on this problem, I want to show you how to use a calculator and do all this, okay? And to find all these numbers. To use the calculator and come up with the final number of here, you know, to do all the calculations, what you do is you go to stat, you could either use TI-84 plus, or even TI-83. So you go to a stat, scroll to the right to the test, and then go to A, is that one, enter. It's asking for the X value. X value in our case is 52. N is 743. Confidence level in our problem is 95%. See here, where is it? 95% confidence level, you put that here, and then calculate. See, these are your interval, which is close to this two. That's how to find the interval. So for here, to find the p hat plus E and P hat minus E. To find these two numbers, this one and that one, are these two. So P hat plus E is this, and P hat minus E is that one. Okay. Here is a good examples. You see, they are taking so many samples, and they notice, let's say proportion of population is the capital P, right? Let's say we know that. They are taking so many samples, and just some of them do not have this p-value. You see this one? This one is start from here to here. So this sample has an interval that this interval does not have this p-value. See, 1, 2, 3, 4, 5, 6, 7, 8. These 8 samples interval do not have this actual value. But the rest, which is 95%, 95% of interval that you establish, they do have the p-value between those two numbers. All right. You know, in most of the problem use 95%, but what if you have, if the confidence is 90%? If it's 90, then what you do is you subtract 1 from 90, that give you 0.1. Here is 99%, I'm sorry. For 0.99 is 0.01. This is your alpha. Alpha is 0.01, but you know, each of these numbers are alpha half. So you have to take these numbers and divide by 2. So each area is 0.05, 0.05. Now here, you go ahead and use your calculator to find the Z. And to do that, I'll show you if you want to use a calculator. I also show in one of the examples. You go to second VARS, inverse norm, and then you type that number, was a 0.05. And when you enter, that should give you this 2.58. So here, you go to second VARS. You see this VARS? Second VARS. And you go to number 3, inverse norm. And then you just need to put this area. This area is 0.05, 0.005. And that gives you that 2.57 or 58. And the reason it's negative because you're calculating for this area. If you want to find this number, which is for the two tails, these two numbers are always equal. It's just one is negative, one is positive. But if you really want to use the calculator and find this value, what is area to the right? What is this for the whole area? The whole area is 1 minus this little one, right? So it's 1 minus 0.005. Which is 0.995. So in the calculator, if you put second and VARS, and then you put that number, I think was, I said 0.995. That gives you the positive one, you see? But you don't have to calculate that. As long as you understand that when you come up with a negative, the other one is always positive. All right. And then this, in this table, you see it for the different numbers. They all are calculated. And one of the homework problems, I show you how to do one by one, show all you, how do you find it, using the second VARS. This is another good example that you have it there. So again, we repeat here, the confidence level associated with Z confidence interval for a population proportion is approximate when you report 95% confidence interval for a population proportion. 95% level imply that you have a method that produce interval that include the actual value of population. So these are all explained about that 95%. 9.4 is just one formula. What if you want to find the N? But if you want to find what size sample shall we pick? If you already know the p-value and you know the margin of the error, you could actually find your N value from this formula. So the 9.4 has only one formula. That's it. And that is this one. All right. So here, I'll put those problems here. These are just a multiple choice. I'm sure you could just go ahead and calculate that. They're saying which one of this is better. See, what I did was, you know, the condition is NP and NQ both must be greater than 10. If you want to know that your sample is large enough, you have to know whether NP and N times 1 minus P are both greater than 10. If they're not greater than 10, then you cannot use the formula. See, all of this, when I check, this one is not. If one of these two is not working, then neither one accept it, okay? NP and N minus P. So you have to do it for calculation for each. Like here, N is 70 and P hat is 0.07. You multiply these two, is 49 is greater than them. But the second one, which is N time 1 minus P, happened to be 2.1, is smaller than 10. So this one sample size is not large enough. So again, in order to have a proper sample size, you want to make sure that your sample is randomly selected, and also N times P and N times 1 minus P is always greater than 10. This is the one that for each value, I show you how to use the calculator and find the Z of half. So Z of alpha half, which is this area, is that. I show you here for each how to do the calculations, okay? These are the multiple choice. In the example, what is it? We always have an estimation. We always have the sample data. We always dealing with one variable. So these are that. And then I think these are all multiple choice. I have it here for you. Number 9, I show you the solution here. This is a good problem because this problem has all the solution, everything for it. This problem has the solution and everything for it. So N was given, and there are two values, more pictures, and X2 is people who complain, 410 people complain, and the other one have more pictures. So again, you calculate the margin of error. First, they want you to do it for these guys, for 640. And then when you find the E, you put it into these calculations. And here I show you how to use a calculator to find that number. And the second X value on part B, they want you to use the second X value, which is 410. And we do that one here, and we do the calculation, okay? So (9.4), there are just 4 problems, and the solution is here. Like for this one, for number 1, I'll show you the solution here, see? So the formula that we use in 9.4 is this one. If it's 95%, which is most of the case, then the Z is 1.96. Otherwise, you always have to calculate the Z. Like for 99% or 90%, you cannot use this 1.96. This 1.96 in the formula is only for 95%, which is most of the cases. Like in these problems, problem number 1, A, B, C, we are using 95%. Even if they don't say it, just use 95%. So all you need to do is P hat is given, E is given. You take all these numbers and plug into this one. Again, if the capital P is not given, proportion of population is not given, you could use proportion of the sample instead in the formula. So this can actually be N is P hat times 1 minus P hat times 1.96 margin of error to power of 2. This is the margin of the error. In our textbook, they are showing with M, but that is margin of the error, okay? And if the value of P hat is not given in a problem, always assume 50%. If the proportion of the sample is not given, like in part B, they don't say that, when they don't say that, then always use 0.5, but I think they give it to you on this one. And also I show you the calculation for this one too. So this 9.4 is just show you how to use that formula to find the sample size. M is margin of the error. Sometimes I use E, sometimes I use M, but that means margin of the error. Okay, so that end of section 9.3 and 9.4.